Welcome to the Valve Studio. My work on the Fullerton amplifier continues. I got both amplifiers on the bench. Remember, this is a dual amplifier, cabinet. It's got a small amplifier, right around 5 watts. It's a 6K6 push-pull design, and I'm using the guts out of a Bendix radio that Jerry gave me. And then for the larger amplifier, I have back here the amplifier out of that Wurlitzer keyboard. And it's going to be ultimately it's going to be a 6L6 design, and it's going to kick out maybe 35-40 watts. That's also push-pull. I'll go ahead and show you what I found. I was a little bit concerned about the size of the OPT on the smaller amplifier, but I think what I'll do is I'll just try it out and see where we stand. Theoretically, the low end frequency sits around 100 hertz, so that's the minus 3 dB point. But when I actually measured this amplifier performance, it actually had a bump in the down in the baseline, so it does get down to 83. Now AJ does tune down half a step, so that makes the low end frequency right around 73 hertz. So we'll just try it out and see what we get, and if it doesn't work out right, I'll get another OPT for the small amplifier. The big one is got not a problem. The output transformer for it's very large, and the power supply transformer for the Wurlitzer is huge. Remember, it's the one that ran like 40 12AX7s or something like that. So it's really got a big, really beefy filament supply. But we'll go ahead and show you what I found, and then we'll come back and I'll kind of summarize where we stand and what's next. Here's the guts out of that Bendix radio. That thing right there on this section here is a power amplifier as well as the power supply. So here's the two 6K6s and the rectifier. And then that's a 6XS-in-7, which is the phase inverter. And I had to do a little bit of fix-up on this thing. One of the coupling capacitors was failed, and it was putting about 20 volts on one of the grids. So I got it fired up, and you can kind of hear it. Well, you're going to hear it here in a minute. I got some signal running in here. So I'm going to check the kind of the power output and kind of turn this up until it gets distortion. You can visibly see it as well as hear it. Also increasing the frequency here. So you can see there's a little bit of clipping down on the bottom side of that waveform. But it's not it's about 4 volts peak to peak, and that works out to be 2.9 volts RMS. So if we go and figure out the power at that level, we got 2.89 squared. And I got a 4 ohm speaker in there, so 4 divides about 2 watts right there. That's not too good. We'll do a little bit better than that when we actually design the Fullerton small amplifier. I'm opting for a 6K6 because that's what is in this Bendix radio, and I actually have a whole bag of these. And I'm reserving the option to switch this over to 6V6s as well. So the power supply design will be able to handle either. And there's other tubes that can use 6F6 and some other tubes in the same kind of family. So down in the maximum ratings section, you can see the plate voltage is 315 volts maximum and the screen voltage is 285. And the bottom table here is for push-pull Class A amplifier for 2 tubes. So their example, they're running the plate and the screen at 285 volts. And they're able to get, you can see the bottom part that you can get out about 10 watts. And the effective load resistance in the plate to plate is 12K. And that kind of confirms what I actually found in the turns ratio. Turns ratio on this guy is about 63 to 1. I started reading this article by Jim Flowers. This is from a 1997 article about winding your own output transformer. And there's a little section in here, I think on page 4 or 5, where he actually looks at calculating the inductance required for the frequency response that you want. You can kind of see there on the right-hand column, about 2/3 of the way down, it comes up with 20.3 henries. Now, this is for a single-ended design. So I went and I referred to RDH4. This is Langford Smith. You can get this freely from the downloads, and this is in page 212 in chapter 5. Talks specifically about how to calculate both the series and the leakage inductance. And so this is actually, this is a matched pair of triodes with a, so you can kind of interpolate this, and I ended up figuring out that my transformers are pretty close to what I need. I'll have to wire them up and see if they're actually real. This is the larger amplifier. This is from that Wurlitzer. You can kind of see the power transformer here is gigantic. I'm trying to keep the weight down so I don't break AJ's back. We'll see how that goes. The output transformer on this amplifier is quite a bit larger because it is an organ, so it does have to go down to hit those lower octaves on the keyboard. I got out my universal bridge and I measured the impedance, the inductance, the series inductance, or the primary inductance of the output transformer, and came up with about 26 henries. This thing uses a 7868 pintode. It's designed for audio amplifiers. And you can see that it runs at 500 volts. Here's the example that they have here for 2 tubes push-pull. This particular keyboard runs at about 425 volts, so it's the right column there. And you can see that they're getting out almost 50 watts, 55 watts. Here are the values that I actually recorded. First thing I checked out was the turns ratio. I figured it out to be 32 to 1. Then the power supply kicks out 425 volts. The plate and the screen are running at 416 and 3 to 3 respectively. That grid is minus 14. The output transformer's got a series resistance of 400 ohms, and the primary inductance is 29 henries. That works out so that the 3 dB frequency is about 36 hertz. So it's well below our requirement of about 73 hertz. Okay, so we have enough parts. Things kind of look pretty good. I will have to do a little bit of power supply design because the 6K6 can't tolerate the plate voltages so high. We'll have to figure out how to handle that because the plate voltages on the larger amplifier are sitting right around 420 volts. We'll have to kind of kick that down and figure out how to handle that. But let's continue on. I'm going to go in and go ahead and do the complete design for the small amplifier, and then I will go over and jump over on the large amplifier. Then we'll start constructing. I did get some Greenlee radio chassis punches in, so, and I also have some, I bought some cake pans, and I'm going to build some amplifiers right on these cake pans and kind of get it all prototyped out before I actually put it in the real chassis. Well, that's it for today. Thanks for watching. This is the Val Studio.